Hello, let me tell you a story. So I was in my secondary school and I was watching a softball match. Then suddenly I was hit by the softball on my head. It was damn painful, so I shouted at the ball, "Oi, why do you hit me so hard?" And the ball actually answered. The ball said, "You got only yourself to blame. Who asked you to hit me so hard?" And then I thought, oh yeah, the ball is right. Because it's the action-reaction pair, right? The ball can only hit me as hard as my head was hitting the ball. So, how hard was I hitting the ball? Let's make some estimates. So let's say the ball was traveling at 30 meters per second when it hits my head. And let's say it was a perfectly elastic collision, so it rebounded at the same speed of 30 meters per second. Now we can calculate the impact force by using a Newton's second law. So the amount of momentum change divided by the time it took for the change to happen. The momentum change can be calculated by the mass times the change in velocity. So what's the final velocity? It's the leftward 30 meters per second. If we take rightward to be positive, then this velocity must be represented by negative 30. So this is the final velocity. Minus away the initial velocity, which is a rightward 30 meters per second. That's why minus away a positive 30 meters per second. So the momentum change turns out to be negative 12. Now we got to divide it by the impact duration. So I'm going to make an estimate of 100 milliseconds, so 0.1 seconds here. So the math tells us that the impact force is negative 120 newtons. So why negative? It must mean that it's a leftward force. So why is it a leftward force? Because we are calculating the impact force felt by the ball. So the impact force exerted by the ball on my head will be in the opposite direction. So the impact force on my head is 120 newtons rightward. Now that's not the end of the story. So later on the same day, the softball hit my friend on his tummy. So I asked my friend, wasn't it painful? And my friend said, no, not painful at all. So again, I was very angry with the ball. So I shouted at the ball, "Oi, that's not fair. Why do you hit me so hard and then you don't hit my friend as hard?" The ball again replied. The ball said, "It's not just about me, you know." And then I thought, oh yeah, the ball is right again. It's action-reaction pair, isn't it? So maybe my friend's tummy did not hit the ball as hard. That's why the ball did not hit my friend's tummy as hard. So let's do the calculations again. So let's again assume that the ball was traveling at 30 meters per second when it hit my friend's tummy. Now I noticed that the ball, after hitting my friend's tummy, did not rebound. It just dropped vertically down. Yeah? So the final horizontal velocity, I think, is about 0 meters per second. The other difference I noticed was when the ball hit my head, it went pop. But when it hit my friend's tummy, it went boing and then dropped down. Yeah? See my friend's tummy? It kind of go inward, right? So that stretches out the impact duration. So maybe that has a impact as well. So let's do the calculation again. So this time around, the change in velocity is not a negative 30 minus 30. It's not a leftward 30 minus a rightward 30. It's just a 0 minus a leftward 30. So the change in momentum this time around is halved, yeah? And the impact duration is also longer, right? Because it went from a pop to a point. So let me just say that the impact duration is doubled to 0.2 seconds. So turns out the force this time around is a negative 30 newtons. So my friend's tummy exerts a 30 newton leftward force on the ball, and therefore the ball exerts a rightward force of 30 newtons on my friend's tummy. Okay, I hope you have learned something from my story. Ta-ta!